Hi everyone. Um, Today's lecture is about using AI and working with ration data, but let me be honest with you. I'm a liar because I looked up at my neighbor lectures, and saw that there is lots of uh, common topics and themes and theses. So I thought about what can I really told you that is unique and there is no other presentation about it. So I came up with the idea to get you some real examples and real work as AI engineer and how to build AI solutions, how to think of it, and what's most important, and how do you need to prioritize your time and resources. So a couple of notes before we start. All comments are beautiful, so you can ask any questions, and discussion is welcome, but uh, of course we have timing, and that's why please raise your hand if you want to ask some questions. And it's very inconvenient for me to monitor all the messages in the chat, so it will be better to raise your hand and ask question by voice if it's appropriate with you. As far as I know, this lecture is recorded, but we can remove all your voices and blur everything related to you if you are if you want it. So I will pay attention to your questions, to your hands at the end of the blocks, not to interrupt the flow and process. So that's me, little bit younger and fitter. I am AI engineer, ML engineer. I work as data scientist. I worked as data researcher. I built some multi-agent AI system and computer vision system, but for last few years, I'm more focused on natural language processing and studies, researches related to Russia and Russian language. I work as AI lead at Chronica Technology. Here is some of our project. Our front project is RIMA. It's Russian Independent Media Archive since 2000s. We have more than 8 million documents from more than 100 independent media sources. Also we have Newsroom. It's in beta test now. It's AI-powered assistant for journalists, sociologists. It can parse, scrape, crawl data from the internet, from the sources that you need, and cluster it, rewrite, summarize for format that you need to. We have Contextum, and it's a web extension anti-propaganda that highlights propaganda claims while user reading use. It's also in beta test now. We launched at One Media, and we're launching now, even today, as far as I remember. Also, I worked with some other stuff inside this inside Chronica. I built chatbot with RAG, and we will talk about some other tools and tasks a little bit later in this presentation. Okay, you as social researcher, as far as I understand, there is more social researchers here. You need to, you know how important terminology is. So to be sure that we are on the same page, let's keep some terms, but let's make it a little bit different. I will show you some real example, and we will go through the whole pipeline and grab terms from this real pipeline. I made up with this example when I was preparing this lecture. So imagine that you are a social researcher who want to investigate situation with Igor Strelkov-Girkin, who is a strange figure in Russia politics, a former Donbass field commander, and he was arrested in July 2023 and sentenced to prison. So you make up with some hypothesis, like after his arrest, pro-war bloggers were prohibited from mentioning him. That's your idea that came to mind. And to support this claim, you want some real data, and you want to prove or not to prove this hypothesis. So how can we do it? We can analyze some major pro-war Telegram channel to understand how the frequency of mentioning him changes after his arrest. And of course, we need to define our task better. And of course, if this mentioning was decreased after his arrest, it doesn't mean that bloggers were prohibited from mentioning him and stuff like that. But we will simplify the task a little bit to show the core ideas and principles. For example, when we started to think about it, we ask a question: what are we looking for? What is mentions of Strelkov? Because it's not as simple as it sounds, because it can be mentioned by some indirect references, like bloggers that in July and stuff like that. And so it's not even easy to say what is mentions in terms of AI. The next one, what is before and after? Imagine that this pro-war channel exists for 8 years, and so 3 years after his arrests and 5 before his arrests. We cannot just calculate amount of mentions before and after. For example, let's simplify. We define 6 months period before and 6 months after. Okay, we have our task, and very important step, because we do anything, because we code, before we do any stuff, is defining the success and evaluation metric. Evaluation metric and the evaluation dataset is a major part of any research, and you know that it's very significant to choose what is success before we do anything, because it's very easy to find anything in unstructured data when you want to just find any insights. And that's why we came up with some evaluation metric, some statistical metric. I will not dive deep into the math and statistics because it's not the topic. So we created some evaluation metric that is clarifying a good result. And now we need to collect the data. So we often, I hear when people misunderstood the terms, for example, collecting data, acquiring data, parsing data, scraping data. And so let's keep the terms here. Usually, there is 3 stages of data acquisition. First one is crawling, and the output of crawling is not the content, it's a list of URLs, of addresses. For example, you go to the media you want to collect data from, and you just collect every URL from the main page of it. You get navigation bar, you can links to ads, some other information, and you get this list of URLs that you can go to and get some content later. After it, you can go to these links and collect more links, crawl from collected from previous step, and go deeper and deeper and deeper. That's called the spider strategy. Next step is scraping. Scraping is where you get the raw content from the previous step. So we get the URL addresses. Maybe we can filter it somehow, and we want to get the content from it. So we use some scraping tools and get raw HTML files or just text, images, whatever. And parsing is a very important step when we break down this raw content into some structure that we can work with. It's like removing ads, store in different format that we can work with conveniently. The output here usually is JSON or CSV, some structured data. It can be anything. It can be Google Drive or Excel table, anything. So in our example, crawling might be on the stage when we choose what channel to collect data from. For example, we go to TGStats or TGPop, get there all the ProWord channel and just crawl all the links to it to analyze it later, to pick one, or to just pick all of them and combine the analytics. But we don't get any content here on this stage. Next one is scraping. In our case, it's Telegram channel. So we can use API method, some Python libraries like Telethon or Paragram, and or we can use web scraping as well. It's not that convenient and fast, but whatever, we can use it. After this stage, we get something that looks like this on the left. So what do we get here? We get all the raw information about posts. We get views, forwards, reactions, ID, and we don't need all this information. And sometimes the structure of this information it's not very convenient, and we want to restructure and get only the information that we want. For example, date, text, views, something like that. After we parse, we get a result looking like that. Of course, date and text is crucial for our task, but my advice is to collect more data in column on this stage because the task can only change and can change, and it's easier to just delete columns than to re-parse and re-crawl everything, because it might be cost efficient, time efficient, and so that's why for this example we get views and reactions. Maybe it will be helpful for us later. Okay, so after these three stages, we have our data. We have data for a year of this Telegram channel. Imagine that we have a few thousands of posts with text and date. So what do we do next? We need to search for Strelkov and Girkin. We need to answer the question: is it mentioned? Is it in this post or not? We can do it by different approaches. The simplest one is just to search for Strelkov or Girkin, just Control F. But as far as we understand, there is much more indirect references and patronymics, initials. And the core task here, as we understand, it's just, I'm sorry, it's just binary classification. So we need to classify does this post mention Stroke-of-Gherkin or not? We don't need to know how much is mentioning, and we just need to know yes or no. And there are other approaches as classical libraries like Natasha, Deep Pavlov, Spicy, and for example, we can use it to extract any entities and match with ours, and it can work pretty well because it understands what is initials, it understands Russian morphology, and we get pretty decent result here. And what is good that it's fast. It's very fast. It's just math algorithms, but we still missed the contexts. We still mixed the euphemisms and direct references. So we can do what we love to do. We can just feed everything to LLM and ask, make some prompt like, is Igor Girkin, also known as Rykov, mentioned or reference in this text or not? We can we can get the probability of it. We can get just yes or no answer. But of course, there is always a trade-offs. It will be much more longer, and LLM can answer differently, even if you ask the same question to the same LLM, answer can slightly be different from time to time. We have hallucination risk, and of course it's costly. And so I want you to choose one option. How do you think if you will be solving this problem? Text, zoom, any letter, any number. You will use keyword sort or classical NLP, or you will feed this to LLM. How do you think? Yeah, I see some twos. Second options. Third one. Okay, that's good. But honestly, in real world, we don't usually we don't use any approach. We just combine them because, for example, we can use some keyword searches initial fast filter if Strelkov-Gherkin is mentioned in this post. We don't need to analyze it later with some more advanced practices because we already have an answer. It will not be changed. And we only left with the posts there that are not mentioning him by from the previous step from keyword search. Then we can use classical NLP, and then we use LLM for the last ones, and this dataset will be much lower than the first one. We can also classify the news by other methods. Is it just news about the weather or something like that? So we don't need to analyze it with LLM. So it's usually very hybrid systems in practice. And I want to talk about how we choose these approaches and how we think, how do we solve these cases. Very important step here is validation. We are talking about the matching and classification step here. So you can just select a random sample of posts. Usually it must be more than 30. You can choose evaluation metrics like precision, recall, F1, etc. And then you can calculate how good your system, how good is your algorithm. And for example, you can calculate how good it handles with some simple keyword search for classical NLP. And you can just stop whatever is good. And the most important thing here is with evaluation metrics, with evaluation dataset, we can iterate. And building AI solutions and building these methods, it's always iterative process. It's not a line, it's like a circle. So we need to firstly clearly define the task. Then we establish some evaluation metrics, construct a simple baseline. It's a very big waste of time to just jump into the coding and choose the most complex and most modern state-of-the-art algorithm and develop it, and only after that measure and see how good is it or not, because it's much faster to iterate over the process. For example, you construct a simple baseline like keyword searching, then you calculate your metrics, and you see it's not so good. So you get back to one step or two steps or three steps. Maybe the problem is in metrics, maybe the problem is in this solution. And it's always how we see the problem and the process. And then you can just Google how to analyze our data. Ask ChatGPT. I have data with mentioning Strelkov-Girkin helped me write the thesis. Is my hypothesis true or not? And it's another important thing here that in real world we don't have time. We don't have a year to study this thesis, to study this topic. We don't have much time, and we need to invest it. For example, we can invest it to select optimal model, to choose some state-of-the-art classical NLP approaches, to choose better LLMs, to work on prompt engineering and stuff like that. Or we can combine some simpler methods, some simpler algorithms together to make a hybrid system to solve this problem. Or we can focus on data quality, on parsing stage, scraping stage, on this all these steps. And we can focus on evaluation metrics. And here is also, I want to ask you, how will you prioritize your time here? How do you think? What is the best investment of time here? Also, please write a number in the chat. I don't see much numbers. I see a second option. Any other thoughts? Hybrid, no. Spoiler alert, there is a correct answer from this. Okay, so as for me, the current answer almost every time is third one, because tools are evolving very fast, and almost every time it's not very big difference between some state-of-the-art tool and state-of-the-art tool from 2 years before it. Your data is crucial step. Imagine that we made some mistake on scraping part and we get only half of the text. Or we scrape only text, but there is no mentioning in the text, and there is picture of him combined with the text. or text in Telegram channel is not printed, it's in the image, and we need some OCR recognition to parse this text. And if any of this problem occur, it will affect your results significantly, much more than any model or evaluation metric, because if garbage in, garbage out, and clean data set with some simpler method and simpler algorithm will give much more much better result than state-of-the-art tool with garbage data set. And this is what I want to talk about a little bit more, because I think it's very important thought, because your time actually, you have limited time, and the acquiring data is data-driven approach. And years before it, decades before it, it was different, because when we wanted to solve some problem, we needed to build a better architecture, better neural network. But today we have tools mostly for everything that we wanna, and you can just pick Natasha, you can pick Deep Pavlov, and the result will not be significantly changed. But the thing is, data that you collect, how do you collect? What data do you collect? How do you structure this data is very important, and it's a crucial step. For example, today's SOTA is Cloud Opus, tomorrow some Gemini model. And I guess a year ago, the CEO of Anthropic wrote an essay about disappearing jobs in next 5 or 10 years. And one of these jobs was data scientist. And it might be a little bit confusing, because how can data science job disappear? But the truth is that today we have LLM that was trained by huge amount of statistical books and math books, and used reinforcement learning by human feedback, by great math teachers, math researchers. So what is our place here? What can we do really? And what we can really do is to define the task, and to filter the data, to clean the data, to observe it, and to make final conclusions and final results. So scraping Telegram posts, any name entity recognition libraries, Python code, it will all be automated, or it's already automated. 2 years ago, 5 years ago, the task, this example that we are talking about, we need a team of data scientists, web developer who will scrape data from Telegram. We need a social researcher to make a hypothesis and make a conclusions. But today you can do it by your own. You can wipe code. You can write and run Python code even without understanding what is Python. And but your role here is really on the both sides. At the beginning, at the end, it's most important how you collect data, how do you choose the topic, how do you choose the thesis, how you will evaluate, what metrics will you use, and all of that. So let's get to some real example that I occurred in my work, and I will give you the whole pipeline, and more important, I will give you how I thought and what decisions I made, and how I solve this problem. So once upon a time, my colleagues came to me and said that we need to extract author information, author metadata from our archive, from RIMA. We have more than 8 million documents, so it's impossible to label all of them manually. So we need automated, scalable solution. And of course, there is lots of nuances and tricks. Like authors can use full names in some media. In another article or another media, it can use initials, pseudonyms, and contextual references. And as always, our resources are limited. We cannot just feed everything to LLM because it will cost us thousands and even hundred of thousands dollars. So we need to figure it out. And to give you context, I will give you context about this archive. We have web sources, print sources, and video sources mostly. On web sources, we do all these stages: crawl, scrape, and parse. Print sources, sometimes people just send us their physical documents, the physical media papers, releases, or send screenshots or whatever, and we need to extract articles from it. So we use OCR methods to recognize the text, and then we reconstruct the article, we combine it together, assemble it, and get the output of articles and metadata. And also have video sources like YouTube videos. We use some audio transcriptions. We also divide it to segments, and every article from every one of it might have an author. Let me just give you more information about our crawling, parsing, and scraping methods because it can be useful. Also, I will send this presentation later, so you will have all of it. We use sitemap-based crawling. It's very fast. Almost every site have XML, but usually it doesn't work. It doesn't support it. But sometimes it's supported very well, and it's very easy to get data from it. We use feed-based crawling, use RSS or ATOM, and we also have integration with Wayback Machine, and that's where we can acquire crawl data from medias and sites that are no longer exists. So then we scrap. It might be tough challenge because there is lots of documents, and we need to support living media sources that can renew their articles. And of course, it's an evolving stage because sites can defend themselves from bots, and usually we use some architecture with fallback. We use the simplest method, then more complex, then another more complex. If we have failure on one step, we just go to more complex method. And there is also paywalls, but we don't avoid paywalls because we respect medias, and often these paywalls is a matter of their survival. So we will not kill them to store them. And then we parse it. After previous step, we have raw HTML. there is lots of garbage in it. Sometimes it can be ad, some navigation bar that we don't need, footer, header, and we need to clean all of it. And this is when we parse it and extract what we need, like date, text, and as you can see on this slide, there is key extracted data, and also there is author information. So if we already get author information on this stage, so what's the problem? Why do my colleagues need me? So problem is always the data, because real world HTML is a mess, is a real mess. Because sometimes it can be clean. It can have special tag for author, and sometimes it can have special tag for author, but inside this tag there is a date or name of the media, or it can be not in HTML but in JSON, and it very depends on media, and it very depends on the situation. So I gave you some context, and we can go to think about how do we think about this problem. Typically, it's very when you solve problems like that, it's always important to touch the data to see what we are working with, and that's why usually I just write simple Jupyter notebook and analyze it. And here is a real example. This is output of my code like 2 years ago or something like that. And you can see here that I went to our archive and just collect some data about author field. And you can see that almost half of our data has non-authors. And also very important thing about our data is that we have top 20 slugs. Slugs is like media sources, and number of documents and articles in our archive from these top 20 slugs is 85%, which is huge. So the distribution is very diverse. And also I counted some another statistics, made some plots. For example, I looked at distribution of non-authors by different sources, and see that it really depends on the source. So, for example, for some sources, we cannot extract author information at all, but for some, we do it pretty well. And then I looked into what is this extracted authors, and I see that we also collect lots of garbage. I wrote very simple script to validate this author field just by the number of letters, to simply distinguish which is 100% garbage from which can be a valid author. And we can see that there is, I called it non-useful authors, and there is lots of them. 75% of our extracted authors are not useful, because we extract some space bars or just symbols. And so we can see here the distribution of our slugs, of our media sources, and we can see that this problem occur mostly in the same slugs, in the same media sources. I made some also, I counted some percentage of distribution. And after it, I counted again some statistics of percentage, slugs, and I see that distribution is very interesting. And also I looked what is inside the valid authors, and I saw pretty interesting things like that almost 80,000 of documents was written by Artyom, just Artyom, and so on. And often you can see also that there is a media name, not it's not an author. The insider is not an author. It's media, and so there is lots of garbage inside it, inside even valid authors. But we can see real authors and real names with number of documents pretty well. So I looked at all of it information, and it was very important for me because I got lots of insight because I wrote anything, because I wrote any code. We firstly we don't need to rush into the into it. So I like to touch the data firstly, and I like to manually label some first data set because it can give you lots of insights of the nature of data. So I made sample from an archive, and of course I cannot just sample random articles because as we saw previously, it's very dependent on the media sources. So I tried to get much more relevant data. I tried to collect sample from different slugs and from different periods of time, because sometimes sites and web development is also evolving, and sites from 2000s and sites nowadays is very different. And I have collected some data set, and then I just label it by myself. I used Label Studio. You can self-host it. It's good tool for manual annotation, and I get some insights from it because I have found out that it's very hard even for me with my eyes to identify the author, because there was so many edge cases. Like author can be it can be news, just a news. So who's the author? The people who wrote this news, or the media itself, or nobody, or sometimes there is citation of the book that is like 90% of the article is a citation from the book. So who's the author of this book, or people who decided to citate it, or sometimes there is like author and photographer. Is photographer an author because he also put an effort in this work or not? So at this step, I got back to my product team and asked them about these edge corners, edge cases, and this helped me to define the task as we mentioned previously. So I rephrase it, and after it, we need to build some tool. We need to build some baseline. And how can we do it? Because there is 8 million of documents, and we cannot just send it to LLM and get the answer. And sometimes very useful practice is heuristics. Heuristics can come from many places, like from the nature of data. In this example, one author usually he writes for limited amount of medias. And if you see, for example, that author who usually wrote only for one media slug occurs in another, and sometimes it's even the very fresh media, and the author unfortunately already passed. So you understand that it's a false result. So we can build some heuristics from this nature, or we can build some heuristics from site, from the code. For example, we see that most of the times at the site, author is at the end of the article in different paragraph, or in the beginning. We can make up lots of these heuristics. But also very good advice is to simplify the task. If you can do it, and simplify the goal, simplify the objective, lower the data set. For example, in here we can use like any library to extract names. We go to every article in our archive and try to extract every name that mentioning inside. And the probability that we will not extract an author is extremely low, because we extract every name. And that's why with articles that we haven't extracted anything, we cannot say who is the author. And that's why we can just skip it, because its probability of finding author there are extremely low. And this approach to lower the data set gave me like huge amount of huge lowering and huge simplifying, because lots of articles that doesn't mention any names. So what can we do? Next, we can build some baseline, but in our case, we already had a baseline. It's our previous approach with parsing, author extraction, and because I couldn't still couldn't feed all the remaining articles to the LLM, I chose some NLP method. Like I came up with heuristics, with set of heuristics. For example, if this name occurs at the very beginning or at the very end of the document, the probabilities that this is an author are higher. Or if there is special HTML tag like author, journalist, it depends on the slug. Probability is higher too, of course. And also I looked for phrases like this article was written by, our journalist will tell you about this stuff, and some similar attributions. And you don't need LLM for it. It's just simple NLP methods, and you can just vibe code it if you don't know how to do it, you can just ask LLM. And after all of these heuristics, we combine them, put some weights on every of this heuristic, and get the probability as the output. So we still need to calibrate this probability to look how it works with our evaluation dataset. And that's why, as far as I said, it's iterative process. You can try this heuristic, but it can be not working, and you know it because you have evaluation dataset and evaluation metric, and you just go back and try something else and try different approaches, and you can see how it works. And we have some articles, and I saw some model B-model distribution that if this heuristic gave me very high probability that this name is the author of this article, most of the times this is true. Like precision was very high, recall was not so high, but also good. And that's why I can lower the data set even more, because I can now I can just I can distinguish these high probability authors and keep them as true. So now we lower data set even more, and now we can finally pass it to LLM to do its job. We have some edge cases, corner cases, and now we can feed it to LLM, and also because of the previous steps, now we can ask not just who is the author of this article, but we can ask for a probability that this specific name, is the author of this article or not. And we can do it not with all the names. We can do it just with the names when we are not sure on the previous steps, where the probability is some mid, like 0.6 or 0.7. You can calculate this threshold after you calibrate your evaluation metrics and stuff. And so what do we see in these two cases? That task can really change, because in real life with the authors, for example, I just came to my colleagues and say that's a hard task, and we cannot extract author from every article with high confidence, because really it can be just in the middle of the text or something elsewhere. And that's why we thought about this from the product strategy, and we thought that maybe we can write about the most significant authors. Maybe it will be easier. And that's why we just manually choose 300 of authors or 200 of authors. And I've tried to find them inside the archive, and it's much easier, because now I have the table where on the left is article, and on the right is all the names mentioned. If this author is not mentioned, we can just skip it, And we can work with initials, pseudonyms, much more easier. And that's how it works now. Of course, I run the whole algorithm on the whole data set. Firstly, I get some authors, get some metadata, but it's always good to get some steps back and to see the whole picture. If it's not working, you can just choose another goal. It's okay. And we see that in these two cases, approach is a hybrid. In the first one, we use some simple search first, NLP, LLM. In the second one, we use heuristics, we use name entity recognition, and only then we use some LLM. And of course, I could spend a lot of time of choosing what library works better for name entity extraction and matching. I could read newer papers, read some articles, but the truth is that they work just fine. And the problem is with the data and with that there can be garbage even in author tag. And that's why data quality and evaluation and data-driven approach is really working most of the times. And also it was very important that I made evaluation data set firstly. So after I tried to get back to, after I tried to build some tool, I used some just simpler model, simpler things, and I always could get back and I always could calculate new metrics, calculate these metrics on new approaches. And it's also a very important step. So here are some takeaways that pipeline, as for me, pipeline is much more important than the chosen model, because it's very easy to switch the model in this pipeline. For example, I used GPT-3 for extracting author, and then I just can write a couple of blocks of codes and switch it to Cloud model or switch it to anything else. And that's why pipeline is very important. And data-driven approach and iterative approach, you first define the thesis, then you define metrics, then you build baseline, then you can deploy it or evaluate it, and it's very circle iterative process. How I set metrics is first, you need to know what is success before you do anything. You don't need to rush to write code to do anything. And communication, of course, is also very important, when you can just go to your colleagues and say, look, this task is a mess. Do we really need to do this or not? And your work as researchers, as AI engineers, it's not just write a code that will parse data, collect data, because you can write this code pretty well with some, while you can vibe code this code pretty easily and it will work just fine. The more important is how you choose the goal and how you make conclusions. And of course, quality data is the most important and crucial step in every stage of this process.